Let's read the problem. Assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 12. Find the percentage that a randomly selected adult has and IQ scores between 86 and 120. Let's sort out what is given. So we are given the mean, which is population mean, mu is equal to 100. And also we are given as the population standard deviation, which is sigma is equal to 12. And I see that there is 82 and 120. These are the x random variables. So this is going to be my x1 and that is going to be my x2. In other words, we are looking for a specified area in between. So if I draw a little bit curve, we are talking about in between. So again, I don't know, we're gonna figure it out. What is this z-score location? So you have to convert to z-score between these two. So let's look into the z-score. What is z-score? So z-score is equal to, has a unique formula, a random variable x minus the population mean over standard deviation. Again, we have everything. So since we have a 2x values, so we're going to use z1. So z1 is x1. I just name it x1. You can name it anything. So x1, what is the x1 here, students? x1 is 86. So 86 minus the mean, population mean, which is 100. That's 100 over the standard deviation, which is 12. Okay, so if I use my calculator, actually, let's take a look here what comes up. Okay, it's going to be approximate somehow maybe. So if you have this kind of calculator, I'm going to show you how to use it, and also if you don't have this calculator, how you're going to get this answer. So well, in this case, seems like this is a fraction. That's the safest way to do. So face the n over d. 86 minus 100, you scroll down and type in 12 and make sure you go to the right and enter. Notice that this is a fraction, but z-table doesn't have any fractions, so you have to use double arrow. So that is too many numbers, but z-table doesn't have any. Only look at this, z-table only have how many? Negative 3.4, and actually on the top row 0.00, so 2 decimal places. Z-table must be converted into, z-score must be converted into 2 decimals. So we can actually do it in the calculator right there. Every calculator you can just use this method. Mode, float, mode, float, and so on. Choose number 2, enter, clear, enter. Negative 1.17. Now, in case you don't have this calculator, how are you going to do this? Make sure its order of operation matters. So you need open parentheses 86 minus 100 close parentheses, then divided by 12. This way you're going to get the same answers. Look at these same answers. So we have negative 1 point. So I have here negative 1.17. Notice that that's the z-score. Let's first finish the z-score, then I'm going to go to the z-table. Then we have another one here, z2. We're going to find the z-score for the second random variable x. So same thing here, I don't have to rewrite the formula, so I know this is going to be my 120. That is my 120. The x is 120 right there, second one, minus the population mean, which is 100, and then of course divided by standard deviation, which is a 12. Standard deviation, which is a 12. And then we're going to use our calculator. If it comes up decimal, is going to be approximate. So again, so let me show you this one again here. So it's going to be 120 minus 100 over 12. Seems like 80 is going to be decimal. Again, my calculator is rounding for me, so I don't have to worry. It makes sure if you see fixed, that means you're rounding somewhere. In this case, 2 decimal places. So 1.67. Again, you don't want to use this. Yes, make sure you use parentheses. 120 minus 100 close parentheses divided by 12. Bingo, you've got the same answers, 1.67. Okay, so that is going to be 1.67. 1.67. Again, it's approximate. Good. So we have this 2z score. Again, we're going to go to the z table right now. So if we go to the z table, on z table has a negative and positive actually. So negative 1.17. Let's take a look which one is that. So this is the negative here, negative z table. Negative 1.17, 1.1. Let me make it bigger. Can I make it bigger? Yeah, very nice. We can make it bigger. So 1.17, 1.1. Let's little bit smaller here. 1.17, 1.1, negative 1.1. Where is the 7? Right here, just right there. It's coming up here. Okay, negative 1.1. So that is our, this z table always give area to the left actually. So this is area to the left actually. Z tables always give area to the left. So we have 0.1210. So let's write this down here. Area is equal to 0.1210. That's area for the first one here. Area for the first one. Now I'm going to go for area to the second one. Area for the second one. So which is 1.67. Again, the same thing. We're going to go right now. This is a negative, so we're going to go to the positive z table. So we're going to go to the positive z table. If we go to the positive z table, again, make sure we know which one we're working on. We're working 1.67. So 1.67. 1.67, 1.67. Here you go. 1.6 and 7 is right here. This gentleman here, the 7, because it's just coming down this one here. So in this case is 0.9525. Again, well, of course this is because of circle. Yeah, make sure, yeah, 0.9525. Again, these are all area between 0 and 1. 0.9525. So we got this one, 0.9525. Let's see, it makes sense to us actually. Okay, let us draw the bell curve and see where is the z-score location. So negative 1.17, negative 1.17, I would go with a little left to this one here. As you see, should be straight line. Sorry about that. Okay, so it's a negative 1.17. That is the z-score. Now this one is 1.67, so 1.567. I would go rather here. That point is the z-score location, and this is the left one, this is the right one. So this is 1.67. So notice that this is what we are looking for. This is the shaded part. We are looking for area in between this shaded region. Okay, so let's see what is the empirical rule says actually. What should be our educated guess in this case here? So look, we are looking for only one area in between, but we found out there are two areas. So what are we going to do? Very simple. Since area of second one, this one give area to the left. This from this point to all the way to the left is 95.25% left. But there is another area up there also, this little bit area from this area. So what we are going to do, we're going to, since this is a two area, we're going to subtract. We take the difference between them actually. So usually the bigger one first. Usually we do the z2 minus z1, area in between, you know, technically formula is area of z2 minus area of z1. So what we're going to do, we're going to subtract it. 0. So the final area is supposed to be, area is equal to 0.9525 minus 0.1210, and that would finally give us 0.83 0.9525 minus 0.1210, and bingo, we needed 4 decimal places, so make sure we go down here. We don't want to lose any data, so yeah, exactly, this is 0.8315. so we technically have 0.8315. Now there is a question asked here, find the percentage. So in this case we're going to move the decimal 1 2 to the right, so the area is supposed to be 83.15 percentage, 83.15 percentage, and that is the area right here actually. Okay, that is area in between 83.15%. so again, what we did, we actually, because since it's in between, we have a 2x values, so we have to find 2z score. And also I want to note it down here, this is a common mistake actually, is to, well, we must put down the x variable first. We must type in the x first here. No matter what, x is smaller or bigger, doesn't really matter. Common mistake is we sometimes put big number first. No, that's not what it is. Whatever the random variable x, that goes first, and mean next, and standard deviation is definitely on the bottom. So, and we use calculator manually anyway, but this is what we are looking for. Again, we are looking for area in between, so we're going to have a 2z score, and once we have a 2z score, we're going to take the difference between them, and that will give us the answer in between. So, and of course this question asks you percentage, we convert it to percentage, and if it doesn't ask percentage, we just leave as a decimal. Usually 4 decimal is the best way in. Thank you.